contains, etc. Okay, so now today I will just give an introduction and then I will start the rectifiers. Okay, so first of all I want to just tell you that what are the prerequisites of the power electronics as well as power electronics and drives. In third year you have studied the power electronics, which is requiring the prerequisites of basic electrical system, which contains the single phase, three phase connections as well as star delta connections. Second prerequisite is analog electronics. Analog electronics means whatever you have studied in the second year with the help of a transistor, diode, the circuits which you have studied. And third prerequisite is the machines or the power systems, means the DC motors, AC motors, induction motors, etc. So here these are the prerequisites for the power electronics and drives also. Okay, now the word power electronics is comprised of power engineering as well as electronics engineering. The power engineering concerns with the generation, transmission, distribution and utilization of power, while the electronics engineering deals with distortion-less production, transmission and reception of data signals with very low power. In power engineering, the efficiency is very important. It means that power should be transmitted and received with a 100% efficiency. While in case of electronics engineering, the importance is given to the distortion-less data transmission. So in electronics engineering, distortion is having the importance, while in power engineering, the efficiency is having the importance. So ultimately, the power electronics concerns the application of electronic principle in power engineering to improve the efficiency of the system. It means that the electronic circuits are used in power engineering to increase the efficiency of the system. Okay, so now coming to the next point of our power electronic system. What is power electronic system? In this, the source may be AC or DC. Okay, it is given to the power converter circuit. This will convert the signal as per the requirement of the load. Okay, so as load requires, whether it requires DC or whether it requires AC, and depending upon the availability of the source, whether it is AC or DC. So this power converter will work as per the requirement of load and source and does the conversion in between these two. From the load, the feedback is given. While taking the feedback, you may connect any sensor also here, okay, to take the feedback. Okay, so here the sensor is connected, the feedback is taken and the feedback is given to the control circuit. To this control circuit, some reference value is previously given. The error between feedback and reference value will be given to the particular power converter circuit, which is the error input. Okay, and as per the error input and the input which is from the source, the power converter will convert the signal. So this is called to be as a power electronic system. So normally the load connected may be any machine or anything which is taking the output. So obviously here, depending upon the requirement of the load and the availability of the source, this power converter circuit will does the working, and that is the main important consideration. It may be called as power modulator also. This is called to be as a power modulator. Now coming to the next point, that is main important thing in this power electronic circuit or system is the power converter circuit. Okay, so power converter circuit can be. Now what it will be? It will be classified into 4 categories. First category is, that category is dependent upon input and the output requirement. Okay, input available and the output required. As I have said you previously in the circuit diagram, this power converter circuit will does the working as per the requirement of the load and the input available, right? So similarly, the categorization is also done depending upon the input available and the output which is to be required. So first one is AC to DC converter. It means that the input is AC, okay, while the output required is DC. So this is AC to DC converter and it is called to be as a rectifier. This rectifier already you have studied, okay. This rectifier is required in the applications like tractions, battery chargers, DC drives, excitation of synchronous motors also. So this is the first category of the power converter circuit, that is AC to DC converter. Second category is DC to DC converter. DC to DC converter means input source available is also DC and for the load the DC is required. So you have to see that DC to DC conversion. So this is DC to DC conversion. This is called to be as a choppers. It means that it chops the voltage. Chops the voltage, it means that it doesn't lessen the voltage. The voltage is remaining same, but it chops the voltage. Means average voltage is chopped. For example, if the 10 volt DC is available, then with the help of a chopper, this voltage can be chopped with the help of a timing. Means for T by 2 times the voltage available, for T by 2 times the voltage is not available. Again for T by 2 it is available. So average voltage of this is to be as a 5 volt. So this is called as a step down chopper also here. The applications of the choppers are DC drives, battery driven vehicles. Means the DC to DC converters, choppers can be required normally in DC applications. Third category is AC to AC converter. AC to AC converter means there are again two possibilities. AC to AC means first is regulator. Regulator means at our home there is a fan and you are requiring to control the speed of the fan. So this is one of the example of speed control of fan. Okay, where the frequency remains constant, okay, but the voltage changes. So this is voltage regulator. AC to AC converter means voltage regulator where frequency is constant and voltage is changing. Second category in AC to AC converter is cycloconverter. Cycloconverter means I have given you example of milk dairy. That in milk dairy there are number of machines which are continuously running, but they are requiring intermittent operation like filling the milk, packing the bag, etc. So these are some intermittent operations. For this intermittent operation, if the machine is kept continuously on, then there is a wastage of power plus wastage of work. So to make it to be as efficient, the cycloconverter is required, which is called to be as V to F control. Means voltage to frequency control. Okay, so it controls the slow speed large AC drives also. Means the drives are having large voltages, large current, no doubt, but the speed is very less. So in the cycloconverter, the frequency is not constant. Okay, so remember there is in AC to AC converter there are two categories, regulator and cycloconverter. In regulator voltage remains same, voltage changes, frequency remains constant. While in cycloconverter frequency is not constant, voltage remains same. Okay. Last category is DC to AC converter. DC to AC means you know it is called to be as a inverter. At our home we are using inverters, or at our institutions, we are using UPS, uninterruptible power supply, when there is a power off. Okay, so these are the examples of our inverter, that is induction heating, UPS, renewable energy systems like solar, wind. From solar and wind, you are having the input in the DC format, but for our working position we are requiring AC. So this is converted from DC to AC. So these are four categories of our converter circuit that we are requiring in our power electronic system, because in hand we are having load, we are having source, only we want to design this particular circuit, that is power converter plus control circuit, and this is categorized in this four fashions, and this is very important as far as power electronic system is required. Okay, now coming to the next point of our power electronics, as we have seen that power electronic converters, power converters are required. Okay, now how to design this power converter? These power converters are designed by using power semiconductor devices. Okay, already you have studied some devices, I know it. Okay, power semiconductor devices are having three categories. First one is uncontrolled, second one semi-controlled, third one fully controlled. Uncontrolled device means what? Diode and power diode. Diode cannot be controlled. You know that as the voltage across anode to cathode goes beyond 0.7 or 0.3 volt, the diode starts conducting. So it is not a controllable device. Okay, semi-controlled. Semi-controlled is your silicon controlled rectifier, which is called to be as a SCR, because it is made up from silicon and it acts as a rectification, so it is called to be as a rectifier. But it is semi-controlled, and that's why it is called to be as a controlled rectifier. Third character is fully controlled. In this fully controlled, there are number of devices like GTO, power MOSFET, power BJT, IGBT. Now here these all are from thyristor group. What do you mean by thyristor group? That thyristor group is called to be as a 4-layer device. Okay, normally it consists of 3 or more PN junctions. Okay, these are called to be as a solid state devices. Why this is called to be as a solid state devices? Because these are made up from silicon